This is a handy way of finding useful components. Go to one of the big resellers, like this is Mouser, but Radio Spares, Farnell in the UK are brilliant, and they all have very similar search capabilities where you can say what you're looking for. So I'm looking for a analog to digital converter. What sort of interface? So I'm investigating SPI, the serial peripheral interface, and what resolution. And I've already convinced myself that 12-bit isn't going to cut the mustard. So I'm looking for 24-bit and above. And then another good indicator is how many they've got in stock. 11,000 in stock seems to indicate it's a fairly popular device. Further down here, 174 in stock. Would you really build something around a component where the availability isn't going to be all that good? So looking at some of the more popular ones, if you open the data sheet, it will tell you the applications, what they kind of envisage that these chips will be used for. So this particular one, industrial process control, weighing scales, gas chromatography. Another one, data acquisition, strain gauge transducers. Another one, thermocouple measurements. So we're seeing a theme here, which is that they're very accurate analog to digital converters, but they're not fast. They're not any use for audio applications. So I think we can eliminate the SPI bus as a potential interface for audio in. So now I'm looking at 24-bit I2C devices, and first thing that strikes me is they haven't got huge quantities in stock. But again, if I open the data sheets and look at the applications, direct temperature measurement, weight scales, strain gauge transducers, battery test equipment, gas detectors. Again, it's very similar to SPI, that they're very accurate, come in very nice packages, but they're not quick. Anything that seems to support the I2C, the inter-IC communications protocol, are nice and accurate, readable devices, but they're not fast. They don't run at audio rates. Where shall we look next? Well, this is the schematic for clouds from Mutable Instruments. So designed by Emily Gillett, however she pronounces it. And this is a module based around the STM32 microcontroller. And this here is an audio codec. So it's both an ADC and a DAC in a single package, and it's the WM8731. So let's have a look at that. So here we are on Mouser again, searching for WM8731, and only 3 hits, and all of them are end of life. Now this may explain why Emily stopped the production of clouds amongst other modules, but that particular chip no longer available. This is it. It was, or possibly still is, made by Wolfson. The WM8731 calls itself a portable internet audio codec with headphone driver and programmable sample rates, and its interface is I2S. And its applications are portable MP3 players and recorders, CDs and mini disc recorders, PDAs and smartphones. So we're getting closer. So this I2S or I2S protocol, what's that then? So this is Wikipedia. It's a standard introduced in 1986, and it stands for Inter-IC Sound. So it's specifically for carrying audio data. It carries 2 channels of audio data. You've got a bit clock that runs continuously, and then a word clock that clocks left and right, and then you've got PCM pulse code modulated data, which is the actual data. And because it's clocked on the leading edges of this word clock, it can cope with a variable number of data bits because they're all left justified. So it can handle up to 32 bits of audio data. Next obvious question is, does the Raspberry Pi Pico support I2S? And the simple answer seems to be yes, it does. There are plenty of people, if you Google it, saying that they've got sound working using I2S, and in fact the Raspberry Pi Pico C SDK extras includes some I2S audio stuff as well, so looks like it's going to be possible.